Hello everyone, welcome back to another episode of Solving LeetCode Hard Questions. Today's question is the longest valid parentheses. The question is as follows. Given the string containing just the characters left bracket and right bracket, return the length of the longest valid well-formed parentheses substring. So for example, if the input is left, left, right, then the longest valid parentheses is the one full bracket at the end, and its length is 2. Let's look at a second example. The input is right, left, right, left, right, right. As we can see here, the longest parentheses substring is in the middle where we have 2 brackets, and the length of it is 4. How do we solve this? Pause here if you like to think independently for a moment. A very common tip here is that when we have a matching pair of something, it's usually useful to use a stack. And that's because we can append when we see the left side and pop when we see the right side. The second tip here is that the input only contains the left round bracket and the right round bracket. This really simplifies the problem, as the data structure stored in the stack can just be the index of the left round bracket. So when we encounter the left bracket, we will append its index to the stack. And when we encounter a right bracket, we will pop it. And the value we pop indicates the matching left bracket's index. Now, when do we know when a valid parenthesis is found? We need to make sure that at any given time, the number of left brackets seen in the stack is more than the number of right brackets. So the condition is when we get a right bracket, because a valid parenthesis has to end with a closing bracket, and when the stack is not empty. When we get a right bracket, we pop from the stack. This means that we have found its matching left side. And we can calculate the length of the substring now. Now, it might be natural to use just the current index and the pop element to calculate the length. However, there is a caveat. Let's look at the example here. Say we're at our last element. We'll pop from the stack, obtaining its matching pair. The equation above will give us the length of 2. But is 2 the longest valid parentheses substring? No. We actually have to know the position of the starting valid parentheses, which is at the beginning of the string. So instead of using the value of the popped element, we can use the value at the end of the remaining stack, which indicates the position before the first starting valid parentheses. And the new equation is this. Okay, so what if the stack is empty? Let's look at the example here. Let's say we're at index 6. At this point, we would pop out the last element from the stack. And in this case, it's the dummy element. We know that from there to the current index is invalid, so we need to start from scratch again. So we'll add the current index 6 back to the stack, indicating the position before the next valid parentheses. Putting everything together, this is what it looks like in Python code. First, we'll initialize the max length and we'll initialize the stack with the element -1. This is because -1 points to the next valid starting point, which is at 0. Then we'll traverse through each element in the string, appending if we encounter a left bracket and popping when we encounter a right bracket. If the stack is not empty, we'll calculate and update the max length using the equation mentioned earlier. Otherwise, we'll append the current index to restart the stack. The final time complexity is O of n, as we're only traversing through the string once. And the space complexity is also O of n. So let's go through an example step by step together. At index 0, the stack would be -1 and 0. Since we're not popping anything, we don't calculate the length. And the max length is 0. At index 1, we have another left bracket, so we append again. And we skip the calculation just like before. And at index 2, we see a right bracket. So we'll pop 1 out in this case. And we'll calculate the length. 2 minus 0 equals 2. And update max length. Next, we see another left bracket. So append. And at index 4, we pop. The length here is 4 minus 0 equals 4. And we update the max length. Index 5, we pop again. And the length is 5 minus negative 1 equals 6. At index 6 here, we pop yet again. But since this is the last element, we'll reinsert 6 back into the stack. And no calculation here. At index 7, we see a left bracket, so append. And at index 8, we pop. So in the end, we'll return a max length of 6. This corresponds to the bracket here. I encourage you to try it yourself with other examples to help with your understanding. That's it for today. Thanks for watching and see you next time.